আমার কথা শোনা যাচ্ছে?
Yes, sir.
Yes, sir.
Okay. Today, instead of
স্যার বলছি স্যার
হ্যাঁ বলো।
স্যার একটা ডাউট আছে স্যার।
কি নিয়ে বলো?
স্যার বলছি যে স্যার
কে বলছো?
একটা স্যার আমি সায়ন বিশ্বাস।
হ্যাঁ বলো।
স্যার আমি বলছি যে একটা ম্যাগনেটিক পোল আছে এম, স্যার ওর চারিদিকে স্যার ম্যাগনেটিক ফিল্ডের স্যার ফর্মুলাটা কি হবে?
ম্যাগনেটিক
স্যার ম্যাগনেটিক ফিল্ডে, হ্যাঁ
মানে এইচ এর কথা তুমি বলছো?
হ্যাঁ স্যার, এইচ কিংবা বি যে কোনো একটা স্যার।
মানে ইন টার্মস অফ পোল?
হ্যাঁ স্যার।
আচ্ছা ঠিক আছে, এটা ডিসকাস করব। ফার্স্টে আমি এইটা একটু আজকে কমপ্লিট করে নিই। মানে ইউ ওয়ান্ট ইন টার্মস অফ পোল, তাই তো?
হ্যাঁ স্যার, পোল।
ওকে ওকে, ঠিক আছে ঠিক আছে।
স্যার আসল কথা কনফিউশনটা হচ্ছে স্যার, আমরা আগে স্যার পড়ে এসেছি স্যার মিউ নট বাই বি এর ফর্মুলাটা স্যার মিউ নট বাই 4 পাই ইনটু এম বাই আর স্কয়ার। আর স্যার কিন্তু বিএল থেকে যেটা দেওয়া আছে স্যার মিউটাকে স্যার নিচে করা আছে।
আরেকবার বলো।
স্যার আমরা আগে পড়ে এসেছি যে মিউ নট ইনটু এম বাই 4 পাই ইনটু আর স্কয়ার।
হ্যাঁ,
আর বিএল থেকে যেটা স্যার করা আছে যে এম বাই 4 পাই মিউ ইনটু আর স্কয়ার।
আচ্ছা এটা আমাকে একটু দেখতে হবে। কেউ একজন তোমাদের কেউ কি পাঠিয়েছিল এটা আমাকে কেউ?
হ্যাঁ স্যার, আমি হোয়াটসঅ্যাপে পাঠিয়েছিলাম আপনাকে।
আচ্ছা ঠিক আছে, আমি একবার ঠিক আছে আমি দেখে তোমাকে পরে আমি
আর
জানিয়ে দেবো।
স্যার সব থেকে এখানটা করে হচ্ছে বি এর ফর্মুলাটা করা আছে, আবার এইচ এর ফর্মুলাটাও তো মিউ থাকার কথা না, কিন্তু এইচ এর ফর্মুলাতে নিচে ওই মিউ নট লেখা আছে।
H equals to mu not H, ঠিক
হ্যাঁ
আছে?
হ্যাঁ
তো ভুল থাকতে পারে, আমি বলেছিলাম না থেরেজার বই ভুল থাকতে পারে, তবে আমি এখনই ভুল বলছি না, আমি ওটাকে ক্ল্যারিফাই করব, ঠিক আছে?
ওকে স্যার।
ওকে ওকে, আমি তোমাকে হোয়াটসঅ্যাপে জানিয়ে দেবো, ঠিক আছে?
ওকে স্যার।
ওকে, তবে হ্যাঁ মানে তোমরা যেটা জানো ঠিকই আছে, এবার আমাকে দেখতে হবে যে ওখানে কি রিপ্রেজেন্ট করেছে, কিংবা আমি তোমাকে পাঠিয়ে দেবো করে, ঠিক আছে?
ওকে স্যার।
Okay. Okay. Today I will continue with PowerPoint presentation because here a lot of diagrams are there. So this is the basic electrical measurement. Basic electrical measurement means how to measure the electrical quantity. So for that, in your say syllabus, that is some of the meters are means we have to discuss, but there are a lot of measuring instrument in electrical engineering. If you want to measure the electrical quantity, so there are a lot of instruments are there. Okay, but your scope is limited, so we just stick to some basic things. And now this is, you see that in this slide the measuring instrument.
Sir, are you showing your screen?
Yes. Oh, it is not showing?
No, sir.
Okay, just a minute. Now it is visible, no?
Yes, sir.
Yes
Okay.
sir.
So in generally measuring instrument are categorized into two distinct instrument. One is primary or absolute instrument, and another is secondary instrument, or you can say primary instrument is the standard instrument also. So primary instrument is basically measures the electrical quantity in terms of কেউ এটা অ্যানোয়েট করলে সেটা কিন্তু খুব খারাপ কাজ করলে। Measuring instrument are basically the two you can distinct it into two category. One is primary or absolute instrument, another is secondary instrument. Primary instrument are instrument which measure the electrical quantity in terms of constant like earth magnetic field and gravitational constant. So here one of the example is tangent galvanometer. In case of tangent galvanometer, it measures the current in terms of the you see in terms of, just a minute. Now you see here we want to measure means we that galvanometer measures the current in terms of tangent of the angle of deflection produced by the current, and also other terms are there: magnetic field strength, radius, and number of turns of the galvanometer. So this is one of the example of the say absolute instrument. Okay. Now, major equipments are secondary instrument. They measure value in terms of, say, you can say that measure value can be determined from the deflection of the instrument. And this instrument has been calibrated by comparison with either absolute instrument or one which has already been calibrated. So examples are different types of indicating instrument, that is the voltmeter, ammeter, wattmeter. So these are the example of the secondary instrument. Now we come to that what are the different types of the secondary instrument. That is the indicating instrument. That name suggests that in case of indicating instrument, that pointer will be deflected corresponding to the electrical quantity, and that will be registered on this scale here. So this is the example of the indicating instrument, and ordinary voltmeter, ammeter, wattmeter are this type of instrument. And now you see this is the recording instrument. That picture suggests that some of the event is recorded for a given period of time. Like XY plotter, you will see this sort of type of instrument in some of your equipment, means in say mechanical or different types of equipment. And in some of you are familiar with electrocardiogram. In that electrocardiogram also, that you can say this is as a recording instrument, because that ECG is basically plotted on a paper. And another is the indicating instrument. Indicating instrument are those instrument which is basically give a particular quantity with respect to certain time. So most common example is that energy meter in the domestic premises. The energy meter is basically, that is the from that energy meter how much amount of energy basically consumed. So that is basically installed in a particular premises, and that power utility is basically collected data from that, and according to that energy consumption, they are that particular say consumer is charges. So these are the different category of secondary instrument: indicating, integrating, and recording instrument. And in our case, in this scope, it will be related to only indicating instrument. Now you see for indicating instrument, that operation of the indicating instrument, three forces are required: deflecting force, controlling force, and damping force. Deflecting force is what? Deflecting force is basically the force which is causes the moving system of the instrument to move from its zero position. You go back to that previous slide, that initially that pointer will be in zero position, but if you connect that voltmeter across any supply, so according to that voltage level, that will be deflected at say certain position, which is basically proportional to that voltage. So that deflecting force is basically responsible for to move the pointer from the zero position. And what is the function of the controlling force? That due to the deflecting force, if there is no such counter force is there, then that deflecting force will be deflect that pointer at a maximum position. So in order to restrict the movement of the pointer, so one opposition force is required. So this force is basically required to limit the movement of the moving system due to the deflecting force, and ensures that the magnitude of the deflection is always that same for a given value of the quantity to be measured. And what is the function of the damping force? Now there is a when the deflecting force and controlling force, they are balanced each other, but still there is some oscillation is there, and that oscillation will be damped out by this damping force. So this force is necessary in order to bring the moving system to rest in its deflected position quickly. Okay. Now there are a term frequently we are using for a particular type of equipment. What is the accuracy of the equipment, and what is the error, and what is the trueness? These are the basically that you can say this is the characteristics of a particular measuring instrument. any type of instrument. It may be electrical instrument or it may be electronics instrument. So first of all, accuracy. Accuracy is basically what? Accuracy, suppose a particular quantity we have to measure, that voltage is 200 volt. So accuracy is basically the closeness of agreement between a measured value and the true value. So suppose a true value is 200 and if your measured value is 199, so we can say that particular instrument is accuracy wise, this instrument is very good. But if your true value is 200 volt and measured value is say somewhat is less than 180, so we can say that the instrument is less accurate. So error is basically very the difference between that measured value. কেউ কিছু বলছো?
হ্যাঁ স্যার, বলছি পিপিটি গুলো পাঠিয়ে দেবেন।
হ্যাঁ, সব পিপিটি নয়, আমি ডিটেলসে তোমাদের পিডিএফ গুলো পাঠাবো।
আচ্ছা,
সেইগুলো তোমরা সেখানে আরো ডিটেলসে পাবে। ঠিক আছে?
হ্যাঁ স্যার।
ওকে, তাহলে কোথায় ছিলাম? এরর। এরর is basically the difference between a measurement and the true value of the measurement. And trueness, this is basically the closeness of the agreement between the average value obtained from a large series of test result and accepted value. So this is basically trueness. Now bias. What is the bias? So bias is basically the difference between the average value and the large series of measurement and the accepted value. So this is basically the difference between the average value and accepted value. Now you come to that frequently you use that term. What is the precision of a particular instrument? But precision and accuracy, this is something is different. Precision is closeness of the agreement between independent measurement of a quantity under the same condition. So precision of measurement is usually indicated by the uncertainty. So precision, for example, say suppose you have to measure a particular true value, say true value is 200 volt, but if you measure this particular value in terms of certain measuring instrument, if you take 5 readings, so if the 5 readings they are close to each other, means maybe it is different from that true value, but that 5 reading they are very close to each other. Suppose that a particular instrument, instead of measuring 200 volt, it is measuring the value or the measured value is say 180 volt, and if you measure 5 times, so that value is closer to 180. So we can say that the instrument is precision is good, but accuracy is poor. And repeatability and reproducibility. So this is basically the name suggests that precision determined under condition where the same method and equipment are used. Mind that this is the example of same method and equipment. Same equipment you have to use by the same operator. So these are the conditions for the repeatability. So we want to measure the voltage of a particular equipment by using that same method, same equipment, and used by the same operator to make measurement on identical specimen. But reproducibility more or less same, only difference is same method but different equipment are used by the different operators. So this is basically the repeatability and reproducibility. And uncertainty is basically the repeated value is basically characterized by characterize the range of value within which the true value is asserted to lie. So this is basically, you can say, this is the range where the true value is lies.
Sir, can you please tell the trueness once again?
Trueness
Sir.
is basically the just you see the definition. Trueness is the closeness of agreement between the average value obtained from a large series of test result and accepted. Say suppose true value is 200 volt. Okay, we took 100 readings and make an average of 100 reading. That trueness is basically the difference between the accepted true value and that average of the reading. So this is basically called the trueness. Is it clear?
Okay, sir.
You have to take several times, you have to take readings of a certain quantity and make an average of that reading and find out what is the difference between that average value and accepted true value. So that is basically called the true base. Okay.
So what is accepted true value? Means the calculated value.
Accepted true value means, say suppose a particular when you are measuring a particular quantity, say 200 volt, that having certain tolerance. Tolerance is basically measured in terms of uncertainty, means it is not exactly 200 volt, but accepted true value, if it is close to that, say 200 plus minus 0.001, so this is basically the accepted true value. Is it clear?
Okay.
True value
Okay, sir.
is
Yes,
true
sir.
value is the exact value. Accepted true value with some tolerance, and that tolerance is basically 200 plus minus. That depends on the accuracy. What accuracy you want from a particular equipment. If your the measured value is means if you want to measure a certain quantity, that accuracy it requires for certain application is very high. So for that case, that accepted true value is 200 plus minus 0.201, 0.301, 0.401, like that. Okay.
Okay, sir.
Sir, I have a question. Sir, trueness and bias এর মধ্যে difference কি তাহলে?
Bias হচ্ছে যে ডিফারেন্স বিটুইন দ্য অ্যাভারেজ ভ্যালু অফ লার্জ সিরিজ অফ মেজারমেন্ট। এইখানে কিন্তু বায়াস আর ট্রুনেস মোটামুটি তুমি বলতে পারো মোর অর লেস সিমিলার, কিন্তু ট্রুনেস এর ক্ষেত্রে যে ক্লোজনেস অফ এগ্রিমেন্ট বিটুইন দ্য অ্যাভারেজ ভ্যালু অবটেন ফ্রম এ লার্জ সিরিজ অফ টেস্ট রেজাল্ট, আর এখানে দেখো বায়াসটা হচ্ছে যে ডিফারেন্স বিটুইন দ্য অ্যাভারেজ ভ্যালু অফ লার্জ সিরিজ অফ মেজারমেন্ট, মানে একটা লার্জ সিরিজ অফ টেস্ট রেজাল্টস, এখানে যে এই যে সিরিজটা তার যে মেজার ভ্যালু, তার নাম্বার অফ মেজারমেন্ট যেটা, আর বায়াসের ক্ষেত্রে নাম্বার অফ মেজারমেন্ট, এই সংখ্যাটা হচ্ছে যে ডিফারেন্স। মানে ট্রুনেস এর ক্ষেত্রে যে সিরিজ অফ মেজারমেন্টটা টেস্ট রেজাল্টটা সেটা অনেকটা ব্রড, মানে স্ট্যাটিস্টিক্যালি যদি তুমি ভাবো যে ট্রুনেস এর ক্ষেত্রে আমি 1000 কিংবা 10,000 রিডিং নিয়ে তার এভারেজ করে ডিফারেন্সটা বার করছি, আর বায়াসের ক্ষেত্রে সে ধরো 10 কিংবা 20 আমি একটা রিডিং নিয়ে সেট অফ রিডিং নিয়ে তার এভারেজ করে অ্যাকসেপ্টেড ট্রুথ সঙ্গে ডিফারেন্স করছি। মোর অর লেস according to the definition it is looked like these two are same, but the difference in the number of measurement. Okay.
Yes, sir.
হ্যাঁ, মানে এখানে হচ্ছে যে ট্রুনেস এর ক্ষেত্রে নাম্বার অফ মেজার্ড রিডিং ইজ মোর কম্পেয়ার টু দ্য বায়াস। আর কারোর কোনো কিছু এখানে আছে বলার? তাহলে নেক্সট স্লাইডে মুভ করছে। এখানে অ্যাকুরেসি আর প্রিসিশন জাস্ট ফর एग्जांपल দেখানো হয়েছে। অ্যাকুরেসি হচ্ছে যে অ্যাকুরেসি বলতে আমরা আগেই ডিফাইন করেছি যে অ্যাকুরেসি ইজ বেসিক্যালি হোয়াট if a measured value is very close to the true value, so we can say that instrument is accurate. Now here you see in first diagram that reading basically provide that high accuracy as well as high precision. High precision কেন না সবগুলো রিডিং দেখো ভেরি ক্লোজ টু ইচ আদার, আর হাই অ্যাকুরেসি কেন না আমরা যে পয়েন্টে যে ট্রু ভ্যালু মেজার করতে চাইছি মোটামুটি সেই ট্রু ভ্যালুর কাছাকাছি আছে। কিন্তু যদি পরের ডায়াগ্রামটা দেখো এখানে কিন্তু অ্যাকুরেসি কিন্তু পোর, কারণ এই অ্যাকুরেসি আমার এর কাছাকাছি যদি ভ্যালু থাকতো তাহলে অ্যাকুরেট বলতাম, কিন্তু আমার এর থেকে অনেকটা ডিফারেন্স আছে সেই জন্য এর অ্যাকুরেসিটা লো, কিন্তু যেহেতু আমার নাম্বার অফ readings they are very close to each other, so we can say this is high precision. And here accuracy is high but precision is low because they are scattered, that measured value are scattered, and here both low accuracy is low as well as precision is low. So this is basically the difference between accuracy and precision. Now there are different types of indicating instrument, that is moving coil instrument, and in our syllabus we will be restricted on PMMC and dynamometer type, moving iron instrument and induction type. There are three different types of instrument according to the principle. One is moving coil, one is moving iron. Moving coil name suggests that the coil is moving, and moving iron is there is a iron core or iron structure is there that is moving, and induction type is basically their induced EMF or in the form of induction. Okay. Now, first of all, we come to that moving coil instrument. So, moving coil instrument, just you see, in moving coil instrument, it basically consists of a permanent magnet. This is basically a permanent magnet that is showing that this is a permanent magnet, this one. And what is the function of this permanent magnet? To provide a magnetic field. And here you see this is the rectangular coil. So this rectangular coil is placed between the air gap of the magnet, and it is free to rotate around its vertical axis. Free to rotate around its vertical axis. Now, when a current is flow through the coil or windings, a torque is developed on the coil by the interaction of the magnetic field and the field set up by the current coil. Okay, and now you see that the aluminum pointer which is attached to the rotating coil, and that pointer is basically moves around the there is a scale. So this is basically the example of the PMMC meter. So that pointer is moving around that scale, and basically a particular electrical quantity is registered on the scale. Okay, and if you see in this structure, there are springs are there, and these springs are basically responsible for to provide that controlling torque. Okay, so now these are the that picture is basically showing one actual PMMC instrument, and that is what is the insight between that PMMC instrument. Okay. And all of you know that basic principle that already we discussed, also maybe listeners are also discussed these things. When a current flowing through the coil, it also produced a magnetic field, and interaction between the induced field and the field produced by the permanent magnet causes a deflecting torque, which results in rotation of the coil. Now, the deflecting torque produced is by this formation, which is given by, all of you know that force is basically, all of you know, NBIL, and that deflecting torque is basically force into distance, that is F into 2R, and that can be represented, deflecting torque is NBI, Newton meter, and controlling torque is basically provided by the spring. So this is C is the spring constant, and theta is the angle of deflection. So, and balance condition, at equilibrium condition, when that pointer comes to a steady position, so in that condition, that TC is equals to PD, or we can say that deflection of a particular PMMC instrument, that is proportional to the measured quantity. So theta is basically proportional to the I. Okay, so this is basically the principle of moving coil instrument. And here one thing is missing, that is the damping force. Damping torque is basically already we discussed that what is the function of the damping torque. In this damping torque induced by obtained by the eddy current set up in the metal former. Metal former means here you see in that coil that will be owned in the metal former. Okay. So that damping force is basically produced by the eddy current, which is basically induced in that metal former, and damping torque that basically depends on the thickness of this former, width of the former, and material used in the former. Generally, that metal former is basically made of aluminum, brass, and copper. These things are used for to forming the metal former. Okay, so this is basically the principle of the moving coil instrument. Okay, now here you see that picture is showing that moving iron instrument. So moving iron instrument, the name suggests that moving iron instrument, that current coil is fixed. Okay, in moving iron instrument, coil is fixed. Is it clear? Better you see this diagram. in moving iron instrument, that current coil are basically fixed coil, and there exists an iron piece. It will be there exists an, this one is iron piece, and that iron piece is basically rotates in the magnetic field produced by the coil. So no permanent magnet is present in such instrument, and this instrument is generally two types, attraction type or repulsion type of instrument. So by using this concept, and as well as here you see that pointer also attached, and this is the scale, and if you observe the scale, scale is slightly cramped at the initial position, and that will be after that scale is more or less linear, and as a damping force or damping torque is basically provided by the air friction damping. Okay. Now we come to that principle of operation of the moving iron type instrument. So this is basically the diagram, and that is one link is given. I would send you this PDF format of that. In that link, that principle of this moving iron instrument also given. So this is basically the link. Okay. Just first of all, I want to discuss that principle, that in case of moving iron type instrument, that current carrying coil is fixed and does not rotate. So this is basically the two fixed coil. Okay, and moving part of the instrument is basically made of a piece of iron in the form of a thin disc. When the coil is excited by the current, these two coil is excited by a current or voltage, it produces a magnetic field, and that movable wave, vein moves in the direction so as to increase the flux of the electromagnet. Or you can say, in other words, moving vein tries to occupy the position of the minimum reluctance. Minimum reluctance means it is basically the maximum flux. So deflection of the iron piece of the vein depends on the excitation current or voltage. Basically, we measure either DC quantity or AC quantity in terms of the moving iron instrument. To measure the excitation current or voltage, an indicator is connected with the spindle, which is fixed with the vein. So this is basically the indicator. And deflection of the iron piece or vein depends on the excitation current and voltage. Now we have to find out that what is the deflecting torque and what is the controlling torque for this structure. So first of all,
I could not understand one thing, sir. How can there be two separate poles in one iron core, south north and then again north south?
Two separate.
To separate the current is in the same direction in the whole coil, but
no. Okay. I am so here means in that iron just maybe.
Yes, sir.
No, in this case.
No, sir. I am talking about the fixed coil.
Okay.
Or if you can also take the example. Yes, sir. You can also take
how the it is north in this end, and why this is south.
Yes, sir.
That similar end. Okay.
Yes, sir.
It is your question. Okay, very good question.
হ্যাঁ স্যার, দুটো এন্ডে স্যার দু রকম হওয়া উচিত তো।
দুটো এন্ডে
দু রকম হওয়া উচিত।
না, দুটো এন্ডে দু রকম হওয়া উচিত মানে এটা কি বলছো বলো?
স্যার মানে হচ্ছে স্যার কয়েলের একটা দিকে স্যার নর্থ কিংবা সাউথ, আর আরেকটা দিকে স্যার সাউথ কিংবা নর্থ মানে। না
দেখো, কয়েলের ওয়াইন্ডিং এর কিভাবে ওন্ড আছে সেটা দেখতে হবে। তুমি যদি একটু লক্ষ্য করো, দুটো ফিক্সড কয়েলে কিন্তু কয়েলের ওন্ডিংটা ডিফারেন্ট আছে, সেটা কি লক্ষ্য করেছো? আমি ওর কোশ্চেনটা পরে আসছি। ওর যেটা কোশ্চেন সেটা একটা ভাইটাল কোশ্চেন, যে কেন নর্থ পোল সাউথ পোল একইটা এতে হচ্ছে আমি যদি কারেন্টের ডাইরেকশনটা ফিক্সড ধরি। আর তোমার কোশ্চেনটা ডিফারেন্ট। তোমার কোশ্চেনটা হচ্ছে যে কারেন্ট মানে আমার এইখানে সাউথ আছে, এখানে নর্থ আছে, এইটার ক্ষেত্রে তো আমার উল্টে যাওয়ার কথা ছিল, নর্থ সাউথ হওয়ার কথা ছিল, তাই তো?
স্যার না স্যার, আমি বলছি যে স্যার কয়েলের একদিকে স্যার উপরে সাউথ, আর আমারও সেম কোশ্চেন স্যার,
আচ্ছা,
নর্থ সাউথ
তোমারও
কেন হচ্ছে?
কোশ্চেনটা সেম, তাই তো?
হ্যাঁ স্যার,
না না,
হ্যাঁ হ্যাঁ
এখানে এই রকমটা ভাবার দরকার নেই যে উপরেরটা সাউথ, নিচেরটা নর্থ, নিচেরটা নর্থ সাউথ। এখানে হচ্ছে যে তুমি বলতে পারো যে এই পিকচারটা হচ্ছে কম্বাইন্ড একটা পিকচার। যখন কারেন্টের ডাইরেকশনটা এই দিকে, তখন হচ্ছে যে এটা সাউথ, এটা নর্থ। যখন কারেন্টের ডাইরেকশনটা আবার উল্টো দিকে, তখন এটা নর্থ, এটা সাউথ। এবার
ও স্যার,
মনে হয় ক্লিয়ার হয়েছে?
হ্যাঁ হ্যাঁ হ্যাঁ, আমি
Okay,
মনে করছি
okay.
স্যার একসাথে নর্থ সাউথ। হ্যাঁ
হ্যাঁ, এবার দেখো তোমাদের আরেকটা জিনিস বলি। আমি এটা প্রথমেই বললাম যে মুভিং আয়রন ইনস্ট্রুমেন্ট ইজ অ্যাপ্লিকেবল ফর মেজারমেন্ট অফ বোথ এসি এন্ড ডিসি। এবার ডিসির ক্ষেত্রে হচ্ছে যে তাহলে তোমার ফিক্সড ডাইরেকশনে থাকবে, যদি না তুমি কারেন্টের ডাইরেকশন চেঞ্জ করো, তাই
Yes,
না?
sir.
কিন্তু is it clear? In case of DC, that current direction is unidirectional. Okay, so
Yes,
for
sir,
that
yes,
case,
sir.
south and north fixed. But if you apply the same instrument in case of alternating current, so after half cycle, that polarity of the or direction of the current is reversed. So that is why this picture, you can say this is a combined picture. This is one instant that when the current is flowing in this direction, so for that case, that is south and that is north. If the current flowing in this direction, that is north and south. It is clear now? I think it is clear.
Yes, sir.
Okay. Now we come to that say deflecting torque and the controlling torque. Now, first of all, here we have to find out the expression of the stored energy in a magnetic field. Okay, so based on this stored energy in the magnetic field, we have to derive that expression of the deflecting torque. And all of you know that stored energy in a magnetic field, which is basically represented in terms of half Li square. এটা তোমাদের সবার জানা যে একটা ম্যাগনেট কয়েল যদি থাকে, তার stored magnetic field is হচ্ছে half Li square. Now, if you consider that certain means change in stored energy of the magnetic field for a particular current, that is denoted as BE is equals to half I square into dl. Now we have to find out that deflecting torque. So before finding deflecting torque, first you have to find out what is the work done required for an infinitely small rotation theta of the moving system, including the moving iron head. So if you want to represent that work done is basically equals to what? Work done is equals to torque into angular displacement, and here we consider that angular displacement is very small, infinitely small, that is d theta. So that work done dw is equals to td into d theta, or we can represent that td into d theta, dw is equals to half I square dl. So this is basically td into d theta is equals to half I square dl. Now from that expressions we can find out that td is equals to half I square dl by d theta Newton meter. So this is basically the expression of the deflecting torque. And here, like PMMC meter, controlling torque also provided by the spring. So that controlling torque is basically magnitude which c theta, and we can represent that in equilibrium condition that td is equals to t theta. So from that we can find out that what is the value of theta. And here you see, in case of that theta is basically equals to what? Theta is basically equals to half, better you write half I square c dl by d theta. Okay, now when we are measuring dc current, so during that time you have to replace that I. Better you write this general expressions as theta. Better you write these general expressions as theta is equals to half I square by c কাজ করছে না ঠিকঠাক, dl by d theta. I is equals to I dc when we are measuring the dc current, and I is equals to IRMS when we measuring the AC current. Okay, so this is basically the deflection, and here you see that deflection, that is the theta here, that theta is basically proportional to, if all the other terms are constant, theta is proportional to I square. Okay, theta is basically proportional to I square. So due to that reason, that scale in that portion, you see initially that scale is more cramped compared to that gradually when it is increasing. So that is the theta is proportional to I square. So due to that reason, and you can easily identify the moving iron instrument or the moving coil instrument by seeing by only that visual inspection. You can identify which one is the moving iron and which one is moving coil instrument. Okay. Now we come to that electro-dynamometer type instrument.
So last part আবার বলবেন কি করে
আইডেন্টিফাই করব, তাই তো? মুভিং কয়েলের ক্ষেত্রে দেখো, মুভিং কয়েলের ক্ষেত্রে হচ্ছে থিটা প্রপোর্শনাল টু আই, তাই তো? সেই জন্য তার স্কেলটা দেখো, তার স্কেলটা মোর অর লেস লিনিয়ার স্কেল, এই যে স্কেলটা। কিন্তু নেক্সট ওয়ান মুভিং আয়রন ইনস্ট্রুমেন্টের ক্ষেত্রে থিটা হচ্ছে যে প্রপোর্শনাল টু আই স্কয়ার, সেই জন্য প্রথমের দিকে ইনিশিয়াল পজিশনে হচ্ছে যে কিছুটা হচ্ছে যে এই ডিভিশন গুলো খুব কাছাকাছি থাকবে এবং গ্র্যাজুয়ালি দ্যাট ডিভিশন ইজ ইনক্রিজিং।
Okay, understood.
Now we come to the electro-dynamometer type instrument. Electro-dynamometer type instrument, you can say electro-dynamometer type instrument is equivalent to moving coil instrument. But what is the difference? Difference is that in case of electro-dynamometer type instrument, instead of permanent magnet, it is basically consist of two fixed coil. ঠিক আছে, এইটা হচ্ছে যে ইলেকট্রোডাইনামোমিটার টাইপের হচ্ছে যে যার ক্ষেত্রে হচ্ছে যে ইলেকট্রোডাইনামোমিটার টাইপ ইনস্ট্রুমেন্টের ক্ষেত্রে ইনস্টেড অফ পার্মানেন্ট ম্যাগনেট হচ্ছে যে আমার এখানে কি থাকে না, দুটো ফিক্সড কয়েল থাকে, দ্যাট ইজ বেসিক্যালি প্রডিউস দ্যাট ফিল্ড। আর এখানে কি থাকে না, এইখানে আমার থাকে হচ্ছে যে মুভিং কয়েল। ওকে, otherwise principle wise they are more or less same, interaction of between the two magnetic field, and here that coil is fixed. Coil is fixed means that is basically equivalent to permanent magnet, and that moving part is the moving coil. So by the interaction of that two field, that torque is generated. But most of the cases electro-dynamometer type instrument is basically used for the watt-hour meter construction. So this is basically the electro-dynamometer type instrument schematic picture. Here you can see this is the two coil, fixed coil, and this is basically the moving coil in between that fixed coil. Fixed coil are basically responsible for create that permanent field or static field, and moving coil is basically if there some current is flowing through the coil, then one field is created, and by the interaction of the two field, then torque is generated, and that torque is basically responsible for the movement of the pointer. And here also you see that spring is used for the controlling torque. Okay, so this is basically much more schematic. That is the two fixed coil, this is moving coil, and this is pointer. And here electro-dynamometer type instrument, that principle wise they are equivalent to moving coil instrument. Now we have to find out the deflecting torque, and in case of deflecting torque is basically represented in terms of this value. In case of moving iron instrument, already we show you that stored energy is basically equals to half Li square, but here instead of single term half Li square, here that stored energy is basically consist of three term. One is half IFS square into Lm, another is half Im square into Lm, and another term is product of IF Im into Am. এবার তোমাদের কোশ্চেন হতে পারে যে কেন তিনটে টার্ম হলো না, দুটো ফিক্সড কয়েল আছে, ওকে, দুটো আমার ফিক্সড কয়েল আছে, ইজ ইট ক্লিয়ার? এন্ড ওয়ান মুভিং, তাহলে ফিক্সড কয়েলের করেসপন্ডিং হচ্ছে যে আমার একটা এনার্জি থাকবে, মুভিং কয়েলের জন্য এবং ফিক্সড কয়েল আর মুভিং কয়েলের মধ্যে একটা মিউচুয়াল ইন্ডাকটেন্স ফর্ম করবে, তো তার জন্য হচ্ছে যে এনার্জি স্টোর হবে। সো বেসিক্যালি stored energy is basically consist of three different parts, that is the individual stored energy for the individual coil and that mutual coupling between the two coils. So that is why that stored energy is basically consist of this three terms. Now we have to find out TD. TD is basically what? TD is basically that d by d theta. If you derivative these things with respect to theta, now you see that LF and that LM for a particular construction, these two are fixed. Okay, half IF square DLF by d theta and half IM square DLM by d theta plus IF IM dm by d theta. So these two terms is basically that is the fixed term, that is why these are zero. So ultimately you will be get that deflecting torque for an electro-dynamometer type instrument is basically proportional to the product of two current, that is IF, that is the current flowing through the fixed coil, IF, and current flowing through the moving coil, into dm by that is the rate of change of mutual inductance with respect to angle, dm by d theta. Okay. Now you see for alternating current generally a electro-dynamometer type instrument কি কাজে ইউজ করা হয়? জেনারেলি এই electro-dynamometer type instrument হচ্ছে যে আমার পাওয়ার মেজারমেন্টের জন্য হচ্ছে যে এটা ইউজ করা। এবারে অল্টারনেটিং কারেন্টের ক্ষেত্রে আমরা IF টাকে যদি IM sin ওমেগা t বলি, IM মুভিং কয়েলের কারেন্টটা হচ্ছে যে একেবারে এক্স্যাক্টলি হচ্ছে যে ফেজে থাকবে না, কিছুটা হচ্ছে যে ফেজ ডিফারেন্স থাকবে এই IF আর IM এর মধ্যে। এবার আমি যদি এই ভ্যালুগুলোকে এখানে রিপ্লেস করি, তাহলে আলটিমেটলি আমার ইনস্ট্যান্টেনিয়াস টর্ক এর এক্সপ্রেশন এটা পাবো। এন্ড তোমাদের এভারেজ ডিফ্লেক্টিং টর্ক একটা ইনস্ট্যান্টেনিয়াস ভ্যালু থেকে যদি এভারেজ বার করতে হয়, তাহলে ইউ হ্যাভ টু ইন্টিগ্রেট দ্যাট থিং TI উইথ রেসপেক্ট টু 0 to t, এন্ড এটাকে ইন্টিগ্রেট করলে আলটিমেটলি আমরা যেটা পাবো আফটার পুটিং দ্যাট ভ্যালু IM into IF cos phi dm by d theta. So in case of spin control instrument, এই থিটাটাকে আমরা k theta is equals to this, তাহলে থিটা হচ্ছে যে IF IM by k cos phi dm by d theta. Okay, and now again you see in case of electro-dynamometer type instrument, the two coils are there. Fixed coil are connected in series with the load. Here you see that fixed coil, they are connected in series with the load, that is the connected in series with the load, and the moving coil connected with the high resistor. Okay, now you see in case of this expression, theta is basically product of IF into IM by k cos phi dm by d theta. When we are apply these things, electro-dynamometer type principle in case of wattmeter, we can show you means it is possible to show that quantity measured by this electro-dynamometer type instrument is basically the power, single phase power, that is the VI into cos theta. Means one of the coil is responsible for that coil connected in parallel, that coil is basically excited by the voltage signal, and that coil is basically excited by the current signal. If you want to measure, P is basically equals to V into I. So one of the cases you supply that voltage Vm sin omega t, another case I is equals to Im sin omega t minus phi. So we can show you that power, instantaneous power measured by this electro-dynamometer type instrument is basically equals to Vi cos theta. Means wattmeter or electro-dynamometer type wattmeter reading is equals to voltage applied to the voltage coil into current flowing through the coil into cosine of angle between voltage and current. It is possible to show because that fixed coil is connected in series with that load, so it is basically responsible for the measurement of the current, and that coil is basically measures that voltage. Or you can say that moving coil is excited by the voltage and fixed coil is excited by the current. Okay. So this is up to this that deflecting type instrument. And another thing we want to as a electrical quantity, instead of voltage and current, we have to measure that resistance also. And this is basically the structure of the series type ohm meter. And here the different component are showing, and that dotted portion is basically represents. So this portion here you see this portion is basically represents in this portion is basically represents that ohm meter, and inside the ohm meter what are the components are there. So this is basically you can say this is the permanent magnet meter, or you can say basic PMMC movement. Also you can consider as that is the Arsenal movement after the inventor. And what is the different thing? R1 is basically the current limiting resistor. Current limiting resistor always connected in series with the unknown resistance. And what is R2? R2 is basically the zero adjustment resistor. And X is what? X is basically you want to measure the resistance of this X. And Rm is the internal resistance of the basic movement. Here Rm is the internal resistance of the basic movement. And E is basically the voltage of the internal battery. Okay. Now we have to measure that meter deflection. So meter deflection is basically measured. So it is not given here. Just you see meter deflection. Theta is basically product of SI into IL. And what is SI? SI is basically the current sensitivity of the movement. SI is what? SI is basically current sensitivity of the movement, and IM is basically the current. IM is basically this current, and if I want to measure this IM current, so we can represent that IM current, that is the this IB current is divided into two parts, IM and I2. So if I apply the concept of circuit theory, so IM is basically IB into resistance of the another part, that is R2, divided by the summation of the resistance Rm plus R2. Now, if I want to represent that IB, so IB is basically equals to what? IB is basically equals to this E by summation of all the resistance. Summation of all the resistance means this X, this R1, they are in series, and that combination will be series with the combination of R2 Rn in parallel. So this is basically the total resistance. So now here you see, in this case, this portion E by this portion is basically represents that current IB. Okay. So after replacing this value, now we represent that theta is equals to SI into IM. So IM is basically this. Now we can show you that theta is basically proportional to what? Theta is basically, if you know that deflection, so by using these equations, you can able to calculate that X value. Now,
So what is I? What is SI?
SI is basically called the current sensitivity of the movement, and it is you can say this is the constant of the meter. Current sensitivity of the movement. It is a constant term. Okay.
Okay, sir.
Now, this is an example of a ohm meter where the load is connected in series with the meter, or you can say this is called series type ohm meter. And in case of series type ohm meter, higher the value of X, যদি ভ্যালু অফ এক্স টা খুব হায়ার হয়, তাহলে কি হবে? IM টা হচ্ছে যে লো হবে এবং থিটাটা হচ্ছে যে অল্প হবে. So in case of this series type ohm meter, X is generally in case of series type ohm meter, generally we measure the resistance for a very higher value of resistance. Okay, but lower value of resistance that cannot be measured by the series type of ohm meter. And another example of ohm meter is, so this is basically the scale of the series type ohm meter. Another one is that sun type ohm meter. In case of sun type ohm meter, that unknown resistance is connected across the meter. Okay, connected across the meter. And here that equations wise they are same. Means when we want to measure that theta is again equals to SI into IM. And again IM, if I want to represent IM is equals to what? IM is basically equals to IB into X divided by X plus RE. So Im is equals to what? Im হচ্ছে যে অন্যপাতের রেজিস্ট্যান্স x ডিভাইডেড বাই Rm প্লাস x। ওকে, তাহলে আবার হচ্ছে যে IB টাকে রিপ্রেজেন্ট করতে হবে। তাহলে এইখানে যদি আবার IB টাকে রিপ্রেজেন্ট করি তাহলে IB টার ফর্মুলা কি হবে? এই IB টাকে আমরা রিপ্লেস করতে পারি হচ্ছে যে E ডিভাইডেড বাই R1 প্লাস Rm x বাই x প্লাস Rm ইনটু x প্লাস Rm, যেটা অলরেডি এখানে আছে। তাহলে এই Im টা ক্যালকুলেট করে নিতে পারলে আবার আমরা হচ্ছে যে এই এক্সপ্রেশনে বসিয়ে দেব থিটার এক্সপ্রেশনে। তাহলে থিটার এক্সপ্রেশনে আমার বসিয়ে দিলে সেখানে আমরা থিটা ইজ প্রপোর্শনাল টু দা x, তাহলে x এর যে আননোন ভ্যালু সেটা আমরা মেজার করতে পারব। কিন্তু এই পার্টিকুলার সান টাইপ অফ ওহম মিটারের ক্ষেত্রে দেখা গেছে যে যদি খুব x টা ভ্যালুটা লার্জ হয় কম্পেয়ার টু RMI, so there is order of value is very high, x value is very high compared to Rm and Ri, so that is change in x does not produce noticeable change in Im. So in the hence যদি Im এর যদি কোনো noticeable change না থাকে, so there will be no such deflection. So for small value of x compared to Rm and R1, change in the x affects the Im and hence theta changes significantly. So sun type ohm meter is basically applicable for the measurement of the low resistance, and series type of ohm meter that will be applicable for, and this is basically you see that is the scale for the sun type ohm meter, and gradually you see first of the cases you see that small value are given, that's in case of the sun type ohm meter. Okay, and in case of series type ohm meter, if you see initially that value is very high. Initially this value, initially this value is very high, this value. Oops. So you know series type ohm meter এর ক্ষেত্রে if you see these things, that is the initial value that is started from 0 and after that 1.5k. So generally it is applicable for the measurement of the higher values, but in case of sun type ohm meter, that you can measure the value in the very low value, that is 0.5 ohm, 0.75 ohm, 1 ohm, 2 ohm, 3 ohm, and higher value it is not means you cannot differentiate whether this value is 10 or infinity. Okay, so generally sun type of ohm meter is applicable for the measurement of the low resistance, and say series type of ohm meter is basically applicable for measurement of the high resistance. ঠিক আছে, so this is up to this discussions. If you have any question.